Hello, Mr. Schoening here, and today I'd like to take a look at the homework problems that go with the Flowing Fluids Synchronous Worksheet. So if you were to scroll down, we've discussed these first three topics already in class, and what we'd like to look at today are the two homework problems that come from the Physics Aviary. So I'm going to just simply move over here to OneNote, get a look at how you want to go about handling these. The first one was the flow rate problem. Now, the way that this problem is going to work is you're going to click on the faucet right here, and that's going to start water flowing into the container. And at some point, you are going to want to stop the water from flowing, so you'll just simply click on that. Now, what will happen is as we do that, the water is going to fill up, and it will give you a little line indicating where the height of the cylinder is up to at that particular moment. Now, as we do this particular problem, what we need to make sure that we do is make sure everything's looking good here. And let me go to the thickness real fast. All right, I'll go a little bit fatter there. That seems to be good. What we want to recognize here is that this particular beaker, when it fills up, let's say it fills up to this line right here. So it's basically at about the 1 meter mark, is that it'll fill up and there will be a volume associated with that. So we'll be able to calculate the volume. We'll also be able to use this timer here and figure out the time it took to get that volume. And we should be aware that that is actually what the fluid flow rate is. Now, we must remember that when we do our standard calculations, when we get the flow rate, that this is not our standard unit. So what we're going to need to do is convert that when we want to get it that way, because this typically the way we will do it if we're using our proper dimensions should be cubic meters over seconds. So we want to make sure that we convert that out as we're doing that. If you really needed to, you could probably Google that and find that. All right, so that's how you'll get the flow rate. Now, what's also happening here is that that flow rate can then be used to calculate the velocity. So what we want to remember here is that there will be water flowing out of this. And what we can do is, as we're trying to figure out those rates, is that we would say that the water flow rate that's coming out of the faucet is the water flow rate that's going into the cylinder. So we'll call that F for faucet and C for cylinder. Now, for the faucet, we want to figure out the speed that's coming out. And we said that what we could do is do the area times speed equation for that one. And we will have the necessary measurements to do that. So that's not a problem. Now over here, for the cylinder that's filling up, we're going to have to do the volume over the time. Now the question now is how do we get that volume? Well, we do have to remember that being that this is a cylinder, that its volume is actually going to be pi r squared, because the top of it is a circle times height. And we can look on the AP equation sheet to find this, but this is going to be the value that we put in here. So basically, we're using the fluid flow rate using the two different forms of flow rate, which is this and this, and we'll use our math to figure that out as we go. All right, so that's how the flow rate problem would be done. The continuity equation, this one's actually probably easier than all the rest. What you're going to be looking at here is that we're going to have a volume of the fluid, or a velocity for the fluid here with an area. Now, we don't have the area given, but we do have the radius. But we do know that when this goes through the pipe will be circular. So it's going to go through a circular radius. So we'll look at it that way. And then over here, we'll have the same thing. We'll have a V2, not drawn to scale because this actually should be faster here than there. And again, we'll have an area too. And basically, we can just simply use our equation. So there's nothing really too special about this one, just using the fluid flow rate. In fact, this one's quite a bit easier, except for at the end, make sure that you convert your speed into centimeters per second. And that's basically about it. So for the homework, hopefully these hints will help you out as you're doing it. If you're having any issues, please feel free to contact me. And as always, have a great day.